Welcome to the deep dive. And for you listening right now, whether you are managing a massive code base, maybe prepping for a technical stand-up, or honestly just trying to understand where the bleeding edge of tech is heading, you are definitely in the right place.
Yeah, we've got a really incredible topic today.
We do. So our mission today is exploring this massive paradigm shift in software development and artificial intelligence. And we're going to be guided by this truly fascinating article from William L. Weaver's Substack, which is called Independent Variables.
Right, and the piece itself is titled Taming the Autonomous Swarm, the Engineer as Archmage in the Era of Agentic IDEs.
It's such a great title. And the premise here is something that challenges basically every assumption we currently have about AI. I mean, we all tend to treat artificial intelligence like this easy magic wand, right? You just wave it and it solves your problem.
Exactly, that's the default mindset.
But Weaver's argument is that treating modern AI like a simple magic wand is actually the most dangerous, computationally destructive thing you can do.
It really is a critical distinction to make right now. Because, we are moving from a world where AI was just a passive tool to a reality where AI is this active autonomous swarm.
Right.
And understanding the rules of engagement with that swarm is vital, because if you don't understand the underlying systems engineering, you're just going to get financially and computationally burned.
Okay, let's unpack this, because usually when we talk about writing software, there's this expectation of absolute, crystalline precision. You write a line of code, the compiler reads it, and the machine just points and says, pass or fail. It's binary.
Yeah, very cut and dry.
But then you step into the world of these new multi-agent swarms integrating directly into our development environments, and suddenly that compiler paradigm feels completely broken.
We're looking at a landscape that is just incredibly muddy.
The diagnostic waters are entirely muddy now. I mean, human intention and autonomous machine reality are blurring together. And Weaver draws a really sharp contrast here between what AI used to be, even just a year or two ago, and the architecture we're deploying today. Right. He calls the old version of AI coding assistants the enchanted quill, which I just love.
It's a perfect visualization. You type, the quill predicts the next word or the next block of code, and you just, hit tab to accept it, or you keep typing.
It was a very linear, predictable interaction. You were basically dealing with a really advanced autocomplete.
Exactly. In that era, the human was entirely driving the vehicle. The underlying tech was based strictly on localized single-turn interactions. You send a prompt, the large language model runs a probabilistic next token prediction, and it just returns a string of text.
But the rollout of Agentic IDEs, these integrated development environments equipped with autonomous swarms, that fundamentally disrupts the whole quill concept.
Oh, completely. It's a whole different ballgame.
And these capabilities are staggering compared to the quill. Weaver points out that these multi-agent swarms aren't just predicting text anymore, they are reading your entire file tree.
Right, and they're architecting software systems, they're autonomously executing terminal commands,
spinning up local servers, writing tests to verify their own code. It's wild. It's like upgrading from a really smart typewriter to a team of invisible ghostwriters who also want to, build the printing press while they're at it.
That's exactly what's happening. They're acting as an entire asynchronous development team operating in the background. And this shift from the quill to the swarm is where the industry has fallen into this massive trap. Weaver points to this trend known as vibe coding.
Vibe coding, right.
Yeah.
The idea that you don't need to understand syntax or system architecture anymore. You just declare a vague intention. You set a vibe and hope the software writes itself.
You type, make me a sleek dashboard for my financial data. And you expect the AI to just handle all the heavy lifting.
But I have to ask, is vibe coding really that bad? I mean, for a novice, isn't declaring a vague intention the entire appeal of AI? Why do I need to micromanage a supercomputer?
What's fascinating here is that the supercomputer doesn't actually know what you mean in a human semantic sense. It doesn't have intuition. It has a high-dimensional vector space. So when you provide a vague prompt to an autonomous agent, you're dropping it into a practically infinite search space without a map. It has to rely entirely on probabilistic traversal to guess your intent.
I think we've all experienced this on a smaller scale. If you're listening to this, think about a time you gave ChatGPT a really vague prompt and got this weird, sprawling, unhinged answer.
Exactly. Now imagine that same chaotic guessing game happening autonomously across thousands of files in a critical project.
Oh, wow. Yeah. Walk us through what that actually looks like under the hood. When I hit enter on Make Me a Sleek Dashboard, what is the swarm actually doing?
Okay, so first, the primary agent receives your prompt. But because Sleek Dashboard is wildly undefined, the agent's confidence threshold for any specific architectural path is extremely low. So it starts searching.
It's looking for clues.
Right. It scans your existing project files, reading thousands of lines of code trying to find context clues. And let's say it doesn't find any. So it spins up an internal sub-agent to generate a hypothesis.
A hypothesis for what sleek means.
Exactly. It decides, probabilistically, that sleek might mean using a specific React library and, say, Tailwind CSS.
Which I didn't ask for, but it's just guessing.
Correct. So it begins writing code for that specific stack. Then, the multi-agent system triggers a verifier agent. This agent attempts to run a build command in the background terminal to see if the code actually works.
Okay, but it guessed the dependencies.
Right, and because it guessed wrong, the build fails.
Yeah.
The terminal spits out a massive error log.
And here is where it gets really dangerous, right? Because an older AI, the Enchanted Quill, would just stop and show you the error.
Yes, but an autonomous swarm is designed to fix its own problems. So the verifier feeds that error log back to the coder agent. The coder agent hallucinates a fix.
Oh, no.
It tries to write a custom Python script to force the incompatible libraries to communicate. It runs it again. It fails again.
So it's iterating on its own failure.
Exactly. Branching further and further away from your original project structure, it starts creating phantom directories, downloading unnecessary packages, just thrashing around in the dark.
It is working incredibly hard to make up for my vague instructions.
Unstructured power without discipline leads to chaos. And the crucial reality that developers are waking up to is that this chaos is not free. Every single step of that thrashing consumes compute.
Right. Which brings us to the actual fuel we are burning when this happens. This maps perfectly to Weaver's overarching framework. He frames this entire technological shift in the language of high fantasy magic.
It's a brilliant systemic isomorphism, honestly.
It really is.
Yeah.
He argues that to survive the swarm, you have to adopt the disciplines of a mage. And the first lesson he introduces is understanding what he calls the well of the ether.
Right. In fantasy lore, magic isn't just wishing for things to happen. It's the mathematical manipulation of raw, chaotic energy from a finite reservoir. Weaver points out that a mage drawing energy from the ether really has to manage that flow.
And he outlines two very visceral ways a mage can fail at this. First, if a mage attempts to draw that chaotic energy too violently or too fast, they overload themselves. Weaver calls it a burnt fuse.
The system just shuts down to protect itself.
Exactly. And second, if they draw too extensively over a long period of time, the well runs completely dry. And a dry well is only replenished by slow underground springs. While it replenishes, the mage is totally powerless.
Stripping away the fantasy metaphor, Weaver is describing the literal mechanics of rate limits and quota management in cloud computing.
So when Weaver talks about depleting our digital mana, he's literally talking about API tokens and compute quotas.
He is talking about the fundamental unit of compute, yes. The ether, that raw energy, is your API tokens. Every interaction with an LLM is broken down into these tokens.
Which is roughly, what, 3/4 of a word?
Yeah, or a specific chunk of code syntax. When you send a prompt, you are charged for the input tokens. When the model generates a response, you are charged for the output tokens.
It's like putting a brick on the gas pedal of a rental car without realizing you're paying for the gas by the millisecond.
That is a very accurate way to look at it. So going back to our vibe coding disaster, when the swarm is reading all your files, guessing at dependencies, failing, and reading the error logs, that is all consuming tokens.
Millions of them.
Yes, and this triggers the two failure states Weaver warned about. Agentic IDEs enforce strict constraints. Let's look at the burnt fuse. In API infrastructure, this is controlled by algorithms, like the token bucket.
Okay, how does that work?
The provider, whether it's OpenAI, Anthropic, or Google, assigns your account a specific number of requests you can make per minute. If your autonomous swarm panics and starts rapid-firing terminal commands and sending those logs back for analysis, it will exceed that rate limit almost instantly.
Drawing too fast, you get hit with a 429 error. Too many requests.
Exactly. The API gateway drops your connection, the fuse is burnt, your IDE just stops functioning, and you are logged out until that short-term limit resets.
And the second scenario, the dry well.
That is your hard monthly quota. Providers place an absolute ceiling on how much compute you can consume in a billing cycle to prevent runaway costs.
Drawing too extensively.
Right. If you let a multi-agent swarm run wild overnight on a vague prompt, it will silently chew through your entire token allocation. Weaver has a line in the text that is brutally accurate. You cannot negotiate with an empty quota.
Man, that is a terrifying reality for a developer working on a deadline. You cannot negotiate with an empty quota. Once you hit that ceiling, the machine stops. You can't ask the AI for a favor.
You are entirely at the mercy of your subscription cycle, which is why you, the listener, need to care about this. Your productivity now has a hard, invisible cap. Managing this flow is the literal difference between a productive day and a frustrating mandated hiatus.
So once you realize your digital mana is precious and finite, the immediate next question is, how do you communicate with the swarm to make sure not a single drop is wasted? If vibe coding is the problem, what is the solution?
This leads to the second rule of the mage, the incantation of precision. In magic lore, asking the ether for fire might yield a warm hearth, or it might incinerate the entire city.
Right, the intent matters, but the boundaries matter more.
Exactly. The mage must explicitly specify the temperature, the duration, and the physical boundaries of the flame. In the context of Agentic IDEs, this means abandoning open-ended requests entirely.
No more vibe coding.
None. You establish deterministic boundaries. You specify the exact programming language, the specific version of the framework, the architectural patterns to adhere to, and crucially, what not to do.
Here's where it gets really interesting, because I have to push back on this a little bit. Doesn't being incredibly specific defeat the purpose of an autonomous AI?
How do you mean?
Well, if I have to tell it exactly which Python libraries to use and explicitly define the whole architecture, am I not just doing the heavy lifting myself? Why am I paying for the AI?
It's a fair question, but to understand why precision is necessary, we have to look at the underlying mechanics of large language models. We talked earlier about the model traversing a practically infinite search space.
Right, the vector space.
Yeah. Every time the model generates a token, it is evaluating the probability of thousands of potential next tokens. It's standing at a crossroad with 10,000 different paths it could walk down.
Okay.
And without constraints, many of those paths look equally mathematically viable to the model, even if they are logically disastrous for your specific software project.
So when I introduce a negative constraint, like saying, do not use arbitrary JavaScript wrappers, what happens?
You are algorithmically pruning the agent's decision tree. You are instantly collapsing thousands of probabilistic pathways down to zero. You're building a fence around the crossroad.
Oh, wow. So the swarm doesn't burn my quota exploring dead-end dependency.
Exactly. You are forcing the attention mechanism of the model to concentrate its mathematical weight purely on the pathways that align with your architecture.
Yeah.
This isn't just about getting the right code. It is fundamentally about saving compute.
Think of it like giving directions to a cab driver. If you get into a cab and just say, take me to the water, the driver has a massive search space. They might take you to a puddle, a lake, or the ocean.
And the meter's running the whole time. You are paying for their probabilistic traversal.
Exactly. But if you say, take me to Pier 39, take the highway, and do not take the scenic route, you have pruned their decision tree. You save time, you save money, and you arrive at the correct destination. Precision is literally a cost-saving measure.
And with AI, the cab driver operates at the speed of light, so the meter runs up thousands of dollars before you even realize you are heading in the wrong direction.
So we've given the swarm precise instructions. We're pruning the chaos. But what is the AI actually looking at while it processes those instructions? Because the AI also have to look at our files to understand where to put the code, right?
It does. And that brings up Weaver's third concept, which might be the most crucial operational practice in the whole piece, warding the sanctum.
Warding the sanctum. So what does this all mean in a practical sense?
Well, Weaver notes that before a mage casts a major spell, they draw protective circles wards around themselves. This ensures the raw magic doesn't accidentally animate ancient relics in the room or consume unintended materials.
It's like bringing a world-class chef into your kitchen to make an omelet. If you don't lock the pantry doors, they might start reading the ingredients on your dog food and getting completely derailed.
That is a perfect analogy. In IDEs, drawing these warding sigils is the .egg exclude imperative. You are aggressively blocking the swarm from seeing raw data logs, compiled binaries, and irrelevant directories.
If we connect this to the bigger picture, why is the AI looking at the dog food in the first place?
Because of the context window. Let's define that, because it is the core bottleneck of modern AI. You can think of the context window as the working memory of the spell or the model.
It's the absolute limit of how much text or code the AI can hold in its brain simultaneously, right?
Exactly. When you boot up an Agentic IDE, the multi-agent swarm immediately begins indexing your workspace to build that context. If you don't explicitly block certain directories, the swarm will ingest everything it can see.
And Weaver gives a fantastic catastrophic example of this. He says, imagine you are building an application, and in your project directory, you have a 50 megabyte CSV file of raw sensor data.
It contains zero architectural logic. It's just rows and rows of numbers.
But the AI doesn't know that. It just sees data. So it ingests 50 megabytes of raw commas and integers during its planning phase.
And this is where the mechanics of the transformer architecture become your enemy. Transformers use an attention mechanism. They distribute mathematical weight across all the tokens in the context window to figure out how the data relates to your prompt.
So it's trying to find a relationship between my precise incantation for a dashboard and a million rows of random sensor numbers.
Yes. And because attention is a zero-sum game within that window, every ounce of mathematical weight given to that CSV file is weight taken away from your actual code base.
Wow.
Weaver refers to this as context dilution. The model gets so overwhelmed by the sheer volume of irrelevant noise that its reasoning capabilities degrade. It forgets what it was supposed to be doing.
Not to mention it consumes an astronomical amount of tokens for zero architectural gain. You just paid for the model to read 50 megabytes of garbage.
Which is why warding the sanctum keeps the attention mechanism focused purely on logic. Just as you need a clean desk to concentrate, you have to curate the AI's environment.
If you don't lock the pantry, it burns your budget. Okay, so we have our precise instructions and a protected workspace. Now, when we actually cast the spell, how much power do we invoke?
This is the fourth rule, the scale of invocation. It's a lesson in mode discipline. Weaver points out a fundamental law of magical conservation. A mage does not summon an elder elemental to sweep the floor.
Right, you don't use a massive earth-shattering spell for a minor chore. But wait, if I have access to the smartest multi-agent swarm, why wouldn't I use it for everything just to be safe? If I have a typo on line 42, why not let the super brain fix it?
Because it's like calling in a heavily armed SWAT team to get a cat out of a tree. Sure, they'll get the cat, but they'll also tear up your lawn and cost a fortune.
Okay, break that down for me. What is the compute cost of the SWAT team?
In Agentic IDEs, you have different modes. Fast, localized editing modes are for single-file tweaks. But deep, multi-agent planning modes instantiate several background subagents.
Like the planner, the coder, and the verifier we talked about earlier.
Exactly. When you invoke a multi-agent mode, you are initializing a complex, multi-step orchestration protocol. The planner generates a JSON payload, hands it to the coder, who writes the syntax, hands it to the verifier, who runs a linting process.
It's a massive bureaucratic process for a typo.
It multiplies the baseline cost enormously. As Weaver notes, using a multi-agent swarm for a misplaced variable is akin to calling down a localized thunderstorm to extinguish a single candle.
Mode discipline is about responsible resource allocation. Knowing when to use a quick Google search versus an exhaustive AI deep dive is a vital modern skill. Don't overcomplicate simple tasks.
Exactly. You match the tool to the task.
But let's say the task actually warrants the thunderstorm.
Right.
We have a massive feature to build. We need the full multi-agent swarm. How do we stop it from going completely rogue?
That brings us to the fifth rule, the binding ritual. In lore, an Archmage forces a summoned entity to state its true name and intentions before releasing it into the physical realm.
You force it to show its cards.
Yes. In IDEs, this is human-in-the-loop orchestration. You force the IDE to generate a definitive implementation plan, an artifact, and halt execution until human authorization is granted.
It's the difference between telling a general contractor, build my house, and walking away for a year, versus forcing them to show you the blueprints before they pour the foundation.
This raises an important question. Why is this checkpoint so absolutely vital? Why can't we trust the verifier agents to catch the errors?
Right. Isn't that their whole job?
It is, but they are vulnerable to hallucination loops. If a swarm hallucinates a flawed architectural approach, say it decides to import a routing library that was deprecated 3 years ago, it passes that flawed premise to the coder agent.
And the coder writes the code, the verifier tries to compile it, and it throws an error.
Exactly. But instead of realizing the library is deprecated, the swarm looks at the error as a puzzle to be solved within its current probabilistic trajectory. It wastes thousands of tokens writing useless code to batch a bad foundation.
And thousands more trying to untangle its own mess.
Yes. It spirals in this loop. The binding ritual short-circuits this before it manifests. You look at the artifact blueprint, see the deprecated library, and explicitly reject it.
You correct the trajectory before a single token is wasted on generating syntax. This is where your true human value lies. You hold the keys. You are the final arbiter of reality.
Taking all 5 of these rules together, Weaver makes a really fascinating historical observation about where we can look for guidance in this new era.
Yeah, this part blew my mind. He concludes that the definitive guide to AI was not written in Silicon Valley, but by J.R.R. Tolkien in the 1950s.
It's a brilliant pivot. He says we are no longer just managing tokens, we are practicing tokens.
The idea that Lord of the Rings is an instruction manual for software engineering is just incredible. Is this just a cute literary parallel, or is there a genuine structural lesson here?
It is a profound observation of systems engineering. Tolkien codified the laws of wielding immense power. Power without precise intent corrupts.
And delving too greedily and too deep, like the dwarves of Moria.
Exactly. They awaken system-crashing consequences, a Balrog, or, in our world, a 7-day API lockout. The wand doesn't make the wizard. The discipline does.
And the craziest part is that Weaver developed this entire article in conversation with Google Gemini 3 Pro. He partnered with the Swarm to map the safe boundaries of the Swarm.
It proves the point entirely. Whether you write code or just use standard AI chatbots, you are the wizard. The AI is the chaotic energy. Your discipline is your only safeguard.
Which leaves me with this final provocative thought for you to ponder. Think about the concept of the Archmage and the novice. We are moving from writers of code to orchestrators of magic. What happens to the next generation who never learns to use the basic, low-level enchanted quill and only ever knows the multi-agent swarm? If the well of ether runs completely dry globally due to a massive infrastructure outage, will anyone still know how to cast a spell with just their own two hands?
It's a huge systemic risk.
It really is. Thank you for joining us on this deep dive. Stay curious, stay disciplined, and keep exploring.